The curve C has this equation here. Sketch C, showing the coordinates of the points at which C meets the axes. Show that dy dx equals 3x squared plus 14x plus 15. The point A with x coordinate minus 5 lies on C. Find the equation of the tangent to C at A, giving your answer in the form y equals mx plus c, where m and c are constants. Another point B also lies on C. So let's just finish this question off. The tangents to C at A and B are parallel. Find the x-coordinate of B. Okay, so it's a long question, isn't it? So I've got it summarized here. So the first thing is to sketch C. So it's a cubic curve, isn't it? If you expand this in your mind's eye, you get x cubed. So we know what an x cubed looks like characteristically. So part A, y equals x plus 1. Was it x plus 3 squared? I'll go back up now and have a look, just to make sure I've copied it down correctly. Yeah, that's fine. So we need to sketch this then. So I'm going to do a little sketch here. You should use a ruler, of course. I'm going to do a tiny sketch just to illustrate it. Now it's an x cubed curve, so x cubed characteristically look like this in terms of their form. So it's going to come down and go back up and come back down. But here there's only two roots. So two of those roots meet. So the first one is at minus 1, and the other repeated root is at minus 3, so it's going to come down, go back up, touch here. So these two roots here are going to meet as one root, so it's going to come down, come through here, turn, maximum there, and go back down. And that was the maximum at minus 3. And this is the point minus 1, wasn't it? Okay, so that's what we've got then for the sketch. Now we can label it, of course. This is the sketch of y equals our function of x. Now what did the question ask us for? We've sketched it as part A, showing axes intercept points. So showing where it cuts the axes. So this point here is when x is 0, and if we put 0 in here we get 1, 0 in here we get 3, 3 squared is 9, 9 times 1 is 9. When x equals 0, and this point here is the point minus 3, 0, isn't it? And this point here, which I'll emphasize now, is minus 1, 0. So there they are illustrated on the picture, the axes intercept points. Show that dy dx, so let's get dy dx now. 3x squared plus 14x plus 15. So y is equal to, expand this bracket, x plus 1 multiplied by, expand this bracket here, x squared, 2 3s are 6, so that's 6x, 3 squared is 9. So that's equal to then. Now run the x through all three, so it's x cubed plus 6x squared plus 9x. So those three are from the x term when it's run through, plus the 1. So it's one lot of x squared, one lot of 6x, and then one lot of 9. So now we need to tally these up then. So that's equal to x cubed. 6 plus 1 is 7 lots of x squareds. 9 and 6 is 15 x's, and plus a 9. So now we can differentiate. So dy dx then. 3 comes down, it's a power rule, 3x squared, 1 less. 2 comes down to be with the 7 to make 14x to the 1 less, which is 1. X differentiates to 1 and there's 15 lots of, and the constant goes to 0. So that's what we wanted, wasn't it? 3x squared plus 14x plus 15. And that was part B. Now let's go back up and look at part B. Show that dy dx, the point A with x coordinate minus 5 lies on C. Find the equation of the tangent to C at A in this form. So that's the next problem then. So A has x coordinate, x equals minus 5. So what does y equal? We'll put minus 5 in here. We get minus 5 plus 1 is minus 4. minus 5 plus 3 is minus 2 squared. So we get 4 times a minus 4 is minus 16. So there's the coordinate then. So A on the curve is minus 5, minus 16. So let me just go back up and remind myself of the question then. Okay, lies on C. Find the equation of the tangent to C at A in this form. So the tangent to C at A, we need to y dx at x equals minus 5. dy dx equals then? It's 3 times the minus 5 squared plus 14 times minus 5, isn't it? Plus 15. So minus 5 squared is 25 times 3 is 75. 5 14s are 70, aren't they? 50 and 20 is 70 with a minus. Plus 15. So 75 minus 70 is 5, plus 15 is 20. So dy dx, the slope of the tangent is 20. So y minus the y coordinate at A is 16, so that's plus 16, because that was minus 16 rather, is equal to the gradient, 20, x minus the value here, minus 5, so that makes that plus 5. Now we have to write that in the form y equals mx plus c. So y equals then 20x. 100, move the 16 over, 100 minus 16 is plus 84. So there's our values of m and c. Y equals 20x plus 84. So the point B now, finishing the problem off, also lies on C. The tangent to C at A and B are parallel. Find the x-coordinate of B. So B lies on the curve. A and B are parallel. Tangent to at A and B are parallel. The tangent to A and B are parallel. B also lies on the curve. So tangent is 20 because it's parallel, it has the same gradient. So what values of x does 3x squared plus 14x is the gradient function? When does that equal 20? So let's solve that first then. Move the 20 over, we get 3x squared plus 14x. 15 minus 20 is minus 5. 3x and x it has to be if it factorizes. It has to be 5 and 1 equals 0. So here we can see that it's plus 5 and minus 1, isn't it? 3x squared plus 15 minus 1x is 14x minus 5. So that tells us that x is minus 5, which we already knew. But the other value was x equals 1/3. That's the x value at B when the tangent is 20. So let's go back up and remind ourselves of the question once again. The tangent C and B are parallel. Find the x-coordinate of B. So the x-coordinate then, as we suspected, so x equals 1/3 at point B.